In this video, we'll look at solving a linear system word problem using elimination. So I wrote down the word problem very briefly. It says, suppose you have $580 and you have 76 bills. Some of them are $5 bills, some of them are $10 bills. How much do you have of each type of bill? That's the question. Alright, the answer, we're going to set it up with particular steps. Our first step is going to be to define our problem using let statements. The let statements say let some letter represent the things we're looking for. And what we're looking for is how many $5 bills do we have and how many $10 bills do we have. You could say F and T, which would be totally fine. But I'm familiar with X and Y and I'm going to stick with that. But use the variable you like. I'm going to let X represent the number of $5 bills. And make sure to say the number of. If you just say let X represent the $5, do you mean the value? Do you mean it's ambiguous? So make sure to say the number of how many of them we have. Similarly, I'm going to pick a variable. I'll choose Y. You can choose whatever you want. And that Y will represent the number of $10 bills. We've defined our variables. Next step, we're going to create a model. That model is going to be the equations based on the word problem we're given. The word problem tells us we have 76 bills. And our bills are X and Y. We have X $5 bills and Y $10 bills. Well, it must be the case that however many $5 bills we have, plus however many $10 bills we have to have a total of 76 bills. I'm going to call that equation 1. And we have a value factor. We know that the $5 bills and the $10 bills all have to add up to $580. So $5 for each $5 bill, that's this 5x, $5 times however many we have, plus $10 times however many we have of those, or 10y, has to equal 580. That's equation 2. Two equations, two unknowns, that's a classic linear system, and we're going to solve it. And in this video, we're solving using elimination. Elimination works by getting the coefficient of either variable, so either the x or the y, getting their coefficients to be the same. Clearly the coefficients are different. I either want to make this x into 5x or make this y into 10y. Either's good. But I'm going to work with equation 1, and I'm going to take equation 1 and multiply it by, well, what do I need to make this x into 5x? Clearly 5. And so take equation 1, multiply by 5, you get 5x plus 5y equals, what's 76 times 5? You might be able to do that in your head. No problem. I'm going to calculate on my calculator. I get 380. And I'm going to call this 1a to remind myself it's still equation 1, but it's equation 1 adjusted, or it's been changed. That's my first step. Now comes my eliminate step. And all of this, I should clearly say, is the solving part. I wrote it in capitals. We defined our problem, we modeled it, now we're solving. I'm still solving. I'm going to eliminate by taking my equation 1a and subtracting equation 2. This 1a is equation 1 adjusted, and you can't just subtract equation 1 from itself, so you have to subtract the other. And that's what we want to do. We want to subtract this to cancel out the x's, just have y's. Let's see that in action. Equation 1a, 5x plus 5y equals 380. And I'm going to take away the second equation, 5x plus 10y equals 580. I'm going to subtract. I put a circle around my minus here to remind me to subtract each thing. It's just my little reminder. 5x take away 5x is nothing. It better be. I was trying to eliminate the x's and I succeeded. 5y take away 10y leaves negative 5y. And 380 take away 580 is going to give negative 200. I'm almost there. I've got rid of the x's. I just need to get these y's by themselves, but it's easy. I have negative 5y which is like -5 times y. What's the opposite of timesing? Dividing. So I'm going to divide both sides by -5, and when I do that, I get y equals, and what's 200 divided by 5? I don't even need to bother with the negatives, they're going to cancel. I could do it in my head, or I can use a calculator, either way. I get 40. Now I know my y is 40. I haven't solved completely yet, but I know the y's. So I'm going to go up here, and now I'm going to sub y equals 40 into either equation, but pick the one you think is easier, and in this case I think 1's easier. So sub y equals 40 into 1, and you get x plus 40 equals 76. How do you get x by itself? Subtract 40 both sides, and you get x equals 36. And now we've got our answer. Let's call that the conclude step. Do you have to write these little capital, okay, Bergman, I'm solving, and I'm modeling, I'm defining? No, I'm just showing you. You do have to write these let statements, you do have to write these equations, and you do have to show all your work. These titles are just help you to frame it. We define, we have our model, we solve it, now we need a final answer. It's a therefore statement. We've found 36 x's and 40 y's, therefore we have 36, what are the x's? Go back to your defining statements. We have 36 $5 bills. And what are the y's? 40 $10 bills. Maybe I'll put a hyphen there for, I think it's $5, $10. Let's put hyphens there. That's it. You're actually done. The last step is optional. That's all the work you have to show. But you could check. There's a check step if you want. It just gives you confidence that your answer is right. And the way we check is we do left side, right side on both equations. So my first equation is x plus y equals 76. I'm going to write that down. X plus y. The right side should be 76. I put an equal sign just here. What's x? 36. What's y? 40. Is 36 plus 40 76? Yeah. So that's good. But they both have to work. If our answer is right, it's going to make the first equation true. Yep, 76 is 76. And the second equation true. So I'm going to check that one. Left side, right side. I can put a little line here if that makes it clearer. What's the left side here? 5x and 10y's. And what's the right side here? 580. Okay, so check this left side. I got 5 times 36 plus 10 times 40. What's 5 times 36? I don't know. My calculator will though. 5 times 36, 180. I think I can handle 10 times 40 in my head. Just add a 0 onto 40. It's 400. And 180 plus 400, that gives 580. Ah, and we've got left side equals right side, so that's checked as well. So we had our answer here, but the check just gives us confidence that since both left sides matched both right sides, that is 76 matched 76 and 580 matched 580, we're confident we've got the right answer. And we're done. We've solved a linear system that was a word problem using elimination. We defined our variables, we set up our model, we solved by getting one equation's coefficient to match the other of the same variable, and we eliminated. When we did that, we got one variable, in this case y, and we used our y subbing into an equation to find x, and that was our answer, the x and y. We've done it.